So this one plugs into a lapel, stick it on just for the live stream, and we're using that one for the broadcast of the room.
For the room, can I use a wireless?
Probably, as long as the audio works okay. Dolls.
Just because I'm going to be typing quite a bit.
Can we swap to a radio mic?
Oh yeah,
typing quite a bit.
Yeah, this should just work as normal.
They won't feed back, will they, from each other?
Yeah, should be fine.
Let me just clip this one on this side. Easy.
Awesome. Do I need to test? Oh, I can hear me.
Yeah.
Awesome.
And I was already getting audio from that. Good luck. I hope that the LLM through your.
Oh, mate, this live demo is going to be very, very YOLO. It's not going to be deterministic.
I wish it's deterministic stuff. You are all live now. So.
Magic. Cool.
Is it? Cool beans.
Yeah. Do you need to...
I'll do it. Cool. All right, grab your seats. We'll finish up with the last talker today. So I will hand over to Christian talking about threat modeling as code. Thanks, mate.
Awesome. Thank you. Hello, everyone. Thank you for hanging out. I know it's the very last session of the day, and I'm the last, speech before drinks, hopefully happening down at Steve's, I believe, unofficially. This afternoon, I get to talk to you about a topic that I'm super, super passionate about. Plus, I'm going to really try and demo some stuff, but I'm demoing it using our favorite buzzword, LLMs. So it's going to be very, I've done this demo like 10 times and 30% hit rate, it's gone way off the rails. So I guess we'll see how this goes. I also have to apologize that after working on these slides for so many days, in my mind, it started to sound like I was just saying threat yodeling, which I think actually works because a lot of the time when people are performing threat modeling, it honestly feels like we're just shouting off the top of the mountain. Anyway, today's presentation, I'm going to talk a little bit about threat modeling, and I need my spectacles now because I'm getting old. A little bit about threat modeling. I'm going to talk and demo quite a bit on this open source project that I've been working on for the last few years, particularly how to leverage CI/CD to automate workflows and business logic checks for your threat assessments and threat models, and then have a look at how artificial intelligence may help, or your favorite non-deterministic postmodern Markov chain ebook machine generation system. It's pretty random, but also kind of fun. I did actually ask an AI to figure out a backronym for what I was trying to say when I was talking about AI, and it came up with this, which I thought was quite funny. And like, don't get me wrong, like, I think there's a lot of really cool use cases. Obviously, the greenhouse gas emissions side of things is not fantastic. Just as a reminder, make sure that you validate the output from your AI slaves. My name is Christian Frichot. I've been doing security for a long time. Last 10 years, I've been focusing and been really fortunate to work in kind of like big tech companies, both in San Francisco and also remote from here in Perth. Now, I would say my time working for HashiCorp and my time at Atlassian, I currently work at Atlassian, certainly started to have a pretty profound impact on my approach and my philosophy to threat modeling, particularly when you want to collaborate with software engineers. So hands up if you work as a software engineer. A couple of hands. Hands up if you work with software engineers. Right? A lot of hands. Okay, awesome. I definitely am a wannabe software engineer. I don't get to get my hands on the keyboards as much as I possibly can. I guess my next question I'm going to ask is, like, who here performs like threat modeling? Okay, cool, good. What about people that think you might be doing threat modeling in the future, or it's a capability that you want to try and expand and grow and develop in your place of work? Okay, awesome. So, personally, I do come from this school of thought. Practical threat assessment can be a really, really valuable and effective way to help address and manage technical risk to help deliver more secure products that your customers can trust. Now, when we think about how threat modeling and threat assessment typically gets executed at enterprise organizations, it might follow something that looks a little bit like this. You've got some product manager and they go, we need to build a widget. They'll start planning the widget, they'll get a project manager, they might spin up a whole bunch of project logistics. Maybe there's some integration points with the security team, like maybe the security team goes, oh, you've got a new project, so you have to come and talk to us. And then the security folks kind of get hooked in and then they start gathering information and they start writing a bunch of documents and people create diagrams and data flow diagrams and there's lots more documentation and then they go, okay, cool, we need to now do a whole bunch of threat modeling workshops. And then there's just like workshops and you're sitting down and you're doing whiteboarding and it's all awesome. And then maybe like the security team has some gating processes like, cool, this feature has been developed, we've done threat assessment, you've done some pen testing and all this other things, and you can finally release it. Now, what's the problem with this? Well, one of them is that it's really boring. Like this is just like, it doesn't sound very fun to me. And you know what software engineers would actually rather be doing? Programming. And like when we think about what we get from this exercise, you really have to question the value of the time invested. Now, if you're doing this well, you should be driving positive change. So the project comes in as an input into your black box of threat assessments, and then the output is the project team agree that there's things that they need to change. They go, you know what, that is a problem. We're going to have to tighten authentication or whatever. And you know, I guess typically the other kind of aspect that's really important is documentation, because quite often systems are never built once, they're probably expanded. People might change, there might be extensions on systems and you have to kind of like, you know, we built this big widget, but now we want to add AI to the widget. So now you've got security coming in to come and do like a threat assessment of those changes. So really good documentation can also really help for future threat yodelers. But a lot of the time it's kind of like, it's done. Like this is, the process is done, we move on to the next one. So like what's the problem here? I think if we take the lessons that we have seen maybe over the last 20 years in the kind of DevOps and agility space, we've seen this like massive industry push for like, we deploy code to production 1 million times a day and we're moving really, really fast. And a lot of threat modeling and threat assessment typically is still based on, I guess, like manual assessments, potentially documenting things in Confluence pages or in Word documents. Obviously, some companies use like threat modeling, threat assessment tools to help this along, but we're kind of like missing a lot of these optimizations. And one of the things that I really enjoyed about working at HashiCorp is that HashiCorp was all about the source of truth in their organization. And their source of truth was code. Everything was as code. And they basically were like, I guess, culturally moving to this point where everything should be like documented in code. Policies, standards, security vulnerabilities, threat assessments, obviously the products that they sell, strategies. And if it's not committed into a repository, then effectively it's kind of deemed as sort of nebulous. So let's bring like DevOps productivity into security. I'm sure someone else said this, but I have also said this. Let's kind of think about infrastructure as code and the approach that infrastructure as code has kind of had on the industry, and let's bring it to threat modeling. And that's where ThreatCL came in. I did the first iteration of this while I was working at HashiCorp. Obviously everything at HashiCorp is as code, and I was like, our threat models should be as code. Hands up if you have used Terraform. Yeah, okay, cool. So Terraform is a popular infrastructure as code product from HashiCorp. I really liked the syntax of Terraform HCL files. If you've ever worked with HCL or HashiCorp configuration language, ThreatCL is built around HCL. You can document your threat models in JSON as well, and the utilities will process them as well, but HCL unlocks a bunch of really interesting kind of capabilities just because of the nature of how the specification is built. So it's Git friendly and it's great for CI/CD. And I'm just going to jump into a terminal. But before that, I actually saw a meme the other day, and I actually thought, for those that work in Terraform, I thought this was quite funny. Because I have definitely been there. Like, I feel like I've done Terraform apply and then everything broke. I feel like this was me, except I would never be able to lift whatever that skeleton is lifting. Not on a good day. Anyway, so I'm going to jump into a terminal. And for those that are comfortable with working, I guess, in HCL, ThreatCL gives you the ability to drop into your editor. And we're just going to threat model a recruiting app. So this is just a really simple example of what the specification looks like. This is not exhaustive, but we can start working on this. Let's say we're building a recruiting app, and it's an app for recruiting whatever people. Maybe we've got use cases like recruiters can list jobs. What's another use case? Someone give me one. What would be another use case in a recruiting app? Yeah. Short listing jobs. I mean, that's okay. You guys are missing the point, but that's okay. How about candidates apply for jobs? That seems quite important. Now, threats is obviously where the power of threat modeling comes in. So you document all the potential bad things that could go wrong, and you can put impacts there, and you can figure out controls. So maybe something like an attacker DDoS's the app, and that would impact integrity. Thank you. Availability. See, this is why I'm doing pair programming on like absolute hard mode. And ThreatCL basically gives you a bunch of utilities, so you can now validate this, right? Okay, cool. So according to the specification, this threat model, and this is a very light example, has been validated. The CLI tooling allows you to view it, which is also not necessarily super exciting, but it kind of gives you this markdown representation of this. Now, for those that don't even want to look at HCL, the specification, you can also generate this interactively. And at this point, you get like a friendly Q&A. So it's like, we'll do this again. Recruiting app. I'll skip all these optionals. Christian. It's a new initiative. It does face the internet. Let's say that the size is medium. We've got information assets. Job listings. This is all the jobs. It's public. We'll add another information asset. Job, applications, applicants apply, and that's probably confidential. Use cases, recruiters list jobs. Jobs, I won't add any more. I won't add an exclusion. Attackers, flood, and DOS the system, and that's availability. And then I'll go no. And then again, it basically kind of spits out like a threat model. Like a fully populated HCL representation of a threat assessment. And this is just a simple example. Obviously, you can add multiple threats. You can add a lot of controls and other bits and pieces. Now, so far, the things that I've shown you, as far as output goes, are not super exciting. So like Markdown output is maybe useful if you're publishing these things into GitHub. GitHub's kind of cool because it can natively render Markdown, so you get like a pretty version of that. But what you actually want to start doing is like building dashboards and doing all sorts of other things. And the tool allows you to do that as well, including generating DFDs. So you can do things like export Markdown. So this will give you a raw Markdown version of the same threat assessment. And then for more advanced functionality, you can start using the dashboard command. Now the dashboard command obviously has a lot more options because it allows you to set kind of the extension types, whether or not you want a dashboard file. You can provide custom templates. So obviously, Atlassian has a particular format for threat assessments. A different company will have a different format. But this will generate like a real simple HTML example of a dashboard. And obviously, if you threw in multiple HCL files, it'll actually generate them for all of the threat assessments. So this is just showing for one. And then this is just like a real simple, like, I mean, I am obviously not a front-end developer, so this is a completely vanilla HTML, but the fact that I created HTML is quite good, I would say. Actually, as a full disclaimer, most of this was written before vibe coding was a thing. If you go back through the commit history, anything over the last 6 months, that is absolutely not true anymore. So I've kind of demonstrated like some of the real simple things. You can define a threat model in this file, and you can kind of interact with it and dynamically process it. Now, as soon as you start doing this, you can kind of shift your paradigm for how you manage threat models. All of a sudden now you can start managing them like code. So that means maybe you have software repositories for your widget product, you can put a threat model in there. And you can put some workflows to automatically process, validate, and publish that. So the widget changes, you update your threat model, the CI/CD picks it up, it republishes your threat assessment. Potentially you can centralize all your threat models into a single repo, which is also potentially useful. You've got a single repo where you've got all your threat models. You can obviously commit to them and you get all the benefits of Git, so you get the version history and you can kind of Git blame and find who messed up on something in the past. Plus you can automatically generate and publish documentation. GitHub Actions, hands up if you've used GitHub Actions before. Okay, cool. So GitHub Actions is GitHub's CI/CD solution. This is just a really simple example of creating a dashboard and exporting it. ThreatCL has native GitHub action magic, so you can just use ThreatCL, and then this one will validate all your HCL files. It will then build a dashboard file, and then in this instance, it will actually recommit the dashboard and all your changes back into the repository itself, which is a little bit kind of quirky, but kind of fun. You think about it, you've got a repo with all your threat models, someone updates one of your HCL files, this thing will publish updates and then recommit it back on top of itself. And what you get when that successfully runs, let's see if I can click over to it, is this. So this is an example that was dynamically generated. And if you click on one of these threat models, this was a threat model that actually had a data flow diagram defined inside of it, and when you publish your dashboard, it renders the PNG of the data flow diagram as well. So you can kind of see there's diagrams and there's some threat model stuff. All right. Okay, so code files for threat models, workflows inside of your CI/CD, but we haven't really touched on like why HCL. And one of the things I really liked about Terraform is its modularization. Like you can include things from other places into your Terraform files, define really, really expansive modules elsewhere, and then kind of import them, and then it kind of influences your build and your environments and stuff. ThreatCL has exactly the same functionality. So you can define central control libraries, and I've got a couple for like the AWS security checklist and a couple of other things. And then you can define a threat model for the product that you're building, and you don't have to retype anything or recreate anything. You can import that information from a central library, which itself you can also then version control. So over time, you can obviously adjust to those controls. Maybe the effectiveness of the controls change over time and things like that. Baselining is also really great. Like the widget that I was talking about before. Maybe you've got a threat model for the widget and the company wants to build a new product on top. You can now build a threat model for that, refer to the threat model from here, which sets a new baseline threat model, and then just kind of add the bits that are different and then publish that as a final result. So this kind of modularization I think is quite powerful, and I'm going to try and figure out how to do this live. So I'm going to get rid of just some of these weird placeholder things, and I'm going to refer to an example on the internet. So up here on this Git repo, I've got an example of like an authentication control defined in a Git repo, like up on the internet. And what I want to do is, I want to first of all import that. So we can add an import into GitHub, ThreatCL, threat CL to a particular file. The format's a bit funny with the pipe. Library, expanded, controls. I'm just gonna try and validate that to make sure it still works. Cool. So now I've imported this, I wanna pull in that authentication control into this threat. So maybe there's a new threat, something like attackers can impersonate a candidate. And I want to import a control, that authentication control. So you define a new import, it's an expanded control, and it was called authentication control, like that. And if I validate it, and then if I view it, you should see it's now added a threat, which is attackers can, I'm scrolling, this is a little funny. Attackers can impersonate a candidate, and then it's dynamically pulled in that centralized control from a separate GitHub repo. Under the hood, this is using another HashiCorp package called GoGetter. So you can actually refer to local files, you can refer to Git repos, you can refer to HTTP assets, and it handles all the other kind of magic underneath quite well. And that really starts to unlock this modularization for your programmatic threat models. Now, doing all this inside of HCL also starts to give you some other really interesting benefits. Hands up here if you've used SemGrep. Not as many hands, as more people using Terraform than SemGrep. That's interesting for a room full of security people. SemGrep is a static analysis tool. They have an open source version, like a community edition, plus also like a professional thing. For those people that put their hand up that they use SemGrep, did you know that SemGrep has rules for Terraform files? Have you? Yeah, okay, so SemGrep, they built the engine to be able to grok HCL because they wanted to be able to provide scanning capabilities for your infrastructure as code. Now, this is awesome because you can write business logic rules in SemGrep to validate your threat models. So for instance, maybe you want to throw a warning if someone has documented a threat and they don't have a control. You don't necessarily want to stop it from publishing potentially, but maybe you just want to throw a warning to them. And using SemGrep rules, we can actually start doing these sorts of business logic checks against processed threat.cl files. So to do that, I do have to export the file, which may be a little bit weird because it needs to build the final product. And then I can scan that processed file. And you will notice that it's going to throw an error. So in this instance, there was that DOS threat that we had documented, and we had not put a control into there. So we should address that problem, and we can address that problem. So what was it again? Availability. So you can see here there's like no controls for this threat, and we want to add an expanded control block. Maybe it's something like CDN. We use a good CDN or something like that. So if we validate that still works, and then we export it, and then we scan it with SemGrep, we should see that should pass, except we've got two different business rules that we documented, or we configured inside of SemGrep. One was the current control is not implemented, so I forgot to put implemented to true. And the second warning was there's no risk reduction value. So you've kind of documented that there is a control, but you haven't documented that it's reducing the risk appropriately. So let's quickly go fix those things. Let's say that we use a better CDN, and it's implemented equals true, and its risk reduction is at least 40%. So we export that, and then we scan it, and this time it passed. Nothing. So in this instance, that threat model met all the business requirements that we had documented inside of SemGrep. And that's quite a powerful capability. Like, we can kind of define requirements that you want for these threat models and manage them as you do manage code, which is absolutely something that we should be doing. This is all still way too manual, right? Why am I opening up a terminal and futzing around with code? What about all them juicy AIs that people are talking about? So ThreatCL also has an MCP server. Now, when I started working on these slides, I was using Cursor. Do people know what Cursor is? It's like an AI IDE. And then a week or two ago, Atlassian, they launched their new Rovo Dev CLI tool, which is, I'm not too sure if anyone here has used Claude Code. It's kind of like the terminal version of Claude Code, but this is the Atlassian version. Now, under the hood, it uses exactly the same models. So it uses Anthropic models. You can select the new OpenAI models if you want. And I thought, I'm going to run this demo on absolute chaos hard mode. I'm going to try and use the Atlassian Rovo Dev AI product to create a threat model from scratch. And it's probably not going to work, but we'll see how we go. In this folder, I have got a recruiting app that I have vibe coded. It's not super exciting, but what I'm going to do is I am going to start. So ACLI is the Atlassian CLI tool for Atlassian customers out there. Rovo Dev is their interactive Rovo chat thing. I'm going to try and run this to see if it can create a threat model for me. You can see it's using Claude Sonnet 4, and similar to Claude Code, we've got the ability to interact with MCP servers. So you can see down here, in this instance, it's got a ThreatCL local MCP server, which has access to a whole bunch of different tools, like interacting with threat models, validating threat models, and things like that. So I'm going to ask it to review the ThreatCL HCL specification, then analyze what this web application is about, draft a preliminary product security threat model using the specification, write this HCL to a file, then validate it. If there are any bugs, directly edit the file and then revalidate it. And then after it's validated, this last bit never works. But after it's validated, I also want you to generate a DFD. So it said, cool, I help you do the thing. It's quickly looked at the HCL spec, so it understands what they should look like. It's going to start going through all the content. Oh, I actually had a backup file, so I wonder if it's going to realize that there is an existing threat model file, but that'll be fine. It's going to look at all the code. Now I have a good understanding of the application. Let me create a comprehensive threat model for this recruitment web app. Based on my analysis, this is a client-side web app that manages things. It's going to try and create this file. Come on. If I ran out of tokens, that would be very funny. Because I actually don't know how many tokens I use on this thing. And I'm using I'm using a trial of the Atlassian product. I'm not even using the real thing. It's definitely doing, okay, cool. It successfully created a threat model file. Now let me validate that this threat model file, it successfully validated that it created a threat model file. Excellent, now let me create the data flow diagram. Come on. But the data flow diagrams that it creates sometimes are interesting. So I did save one that it created earlier that I was like, that's actually not terrible, but sometimes it is very not good. Which is, I guess, good for security professionals. I don't think AI is necessarily going to take all of our jobs just yet. Or maybe this will fail, and then it'll go into a loop, and then it'll chew up all my tokens. Oh, it actually did run into a model because it had a typo. I see there's a typo. I wrote thread model. Oh my God. What are you doing? I love this. I don't think, this could actually be an error on my behalf. I don't think it realizes that this tool just needs the file name. I think it might be trying to give it the raw string, which is why it's going to fail. But I'm still crossing my fingers for this little AI, non-deterministic Markov chain ebook generation machine. Oh, no, it created something. Okay, cool. Perfect, I have successfully created this thing. Oh, now it's listing the contents. Okay, cool. Here's a summary of the things I did. Oh God, I analyzed the, yeah, okay, it did. I need a different AI to summarize the output of the AI. Apparently I only used 37,000 of my session context. And also obviously because it's an Atlassian product, do you want me to create you Jira work tickets? Which is really lovely, and it can go and do that, but maybe not today. So let's see what it actually created. So inside of the threat model folder, there is 2 files. If I look at the threat model HCL, it's got security threat model for the UI5, which was an open source thing that I used. It created some additional attributes. It's a single page application. Information assets, candidate personal data, recruitment process data, application source code, HR personal access to the website. There's some exclusions. It documented some of the third-party dependencies, which is quite funny. It's found that there's potentially cross-site scripting threats. It's suggesting that we should have input validation and sanitization. Currently, it's not implemented, which is good because I definitely have not implemented any of these things. And then if I keep on going down, so it's obviously documented quite a lot of things. Finally, it's also done this data flow diagram. So the specification allows you to programmatically define a data flow diagram. We're going to open this file up and just see what it looks like. Oh yeah, this is definitely something. I don't know what is happening in this picture, but this is an example of those times where you really do want to review the output, because I don't know why it looks anything like that.
That's a good CDN.
I mean, yeah, I love it. It's working as intended, right? Like, oh my God. It's exactly, yeah, that's true. It is just going to blindly follow my instructions. So anyway, that's the end of what I was going to demo. That it actually got further than it has in some of the dry runs. So yay. Anyway, I guess the takeaways for me are, depending on your scale of organization, how often you do these sorts of assessments, and also if you work in kind of like software product style companies, these sorts of approaches absolutely are things that you should be investigated. Now, ThreatCL is quite a big hammer for a lot of use cases. Even just like starting with templated markdown files in your repositories, like it's a really good start, and it costs you absolutely nothing. But as soon as you start automating your business logic checks inside of CI/CD and generating kind of computer readable output, I think you start to unlock a lot of really powerful features. In particular because I think we're seeing this big phase change where a lot of enterprise knowledge management tools are all about like search indexing and being able to go like, hey, the company's building this new product and it looks a little bit like this other product. Have we ever done a security assessment of that thing? And this obviously helps along that journey. Maybe LLMs can help. I don't know if this was necessarily a good sales pitch for that or not. And obviously don't forget to verify their outputs. Thank you very much. That's all I had. Questions? Yes?
So, based on what you've shown us, it looks like whether or not the control is implemented or valid at any point in time still seems not necessarily linked to what might be changing in the code.
Exactly.
Have you seen or played around with if we take an example of you have a risk that data might not get redacted where it's supposed to be, and in control we implemented a redaction functionality.
Ooh.
That using like an LLM on commits to look at what's changing in the code, read the threat model and go, hey, they forgot to input the redaction thing.
Brilliant. That's people should be doing that. Like, yeah, I mean, obviously, like, blindly committing things from the AI overlords is obviously something that a lot of software companies are dealing with right now. We're definitely seeing a big push for like, well, can we get to the point where the reviews are automated and like, but I mean, that's a really good example. Like, you could definitely, in theory, build up non-deterministic style things to go. In particular, if you can already hook in agents into your PR workflows or your reviews, you could literally go, does this change influence or anything inside of this threat model file? And because obviously knowing how to read the spec is quite simplistic for a text machine, I mean, that's awesome. It literally could be, cool, yeah, you know what, this does. We think this change that you've implemented for authorization controls adds a couple of controls, or it potentially bumps the risk reduction targets up or whatever. No, it's a great idea, and I'm absolutely going to take that to work. Any other questions? Yes?
Are you feeding the LLM like knowledge of Stride or ASBS or like giving it that background information?
No, and that's, yeah, good point. It definitely has it in there, because I think the new, like Claude Sonnet or whatever it is a pretty up-to-date model, and they certainly would have slurped up all the open source OWASP material. So they would have some of that, but you're right, none of that was pre-prompted. And you could certainly make that smarter by adding more layers of knowledge in the front. We're doing a lot of exploration right now for auto code review things, but we're feeding it knowledge of our secure coding guidelines. So it's not just about a software developer getting an automatic peer review that says, this is how the industry addresses cross-site scripting. It's about understanding how we actually do it using the platforms and frameworks inside of our organization. So that could definitely be better with targeted stuff.
And you're relying on the developer to go and update the HCL so they put a control in place. But have you had anybody driving it from a Jira ticket to update to the HCL?
No.
Because developers love to close the tickets off.
Yeah.
They'd rather do that sometimes than update HCL code.
Yeah, I guess the next future panacea step would be automation that can look at a Jira ticket and has a relationship with your Git repo, and it can action the Jira ticket is update the threat model, here's the repo, and then an agent picks it up and does it. So in theory, we're seeing orchestration things that can help achieve that, but I haven't seen anything like that. HCL files, like it's working at HashiCorp and seeing how they work. So the HashiCorp cloud platform is obviously built entirely on Terraform and their own container orchestration system and stuff like that. I'd never seen HCL like they had written inside their own company. And that certainly for me was a big, like, working at places that used a lot of Terraform, seeing the massive differences between how people did it. This falls a little bit into that. Like, I kind of feel like if your comfort level with HCL is light, you can probably keep them simple. If it's much more complicated, using modular control libraries and stuff like that could be something to explore. Yes?
Is this something that Atlassian is already kind of doing? Like, following his code, are you trying to push them to?
Yeah, we're definitely trying to push this way. It's complicated, Our scale is big. We do a lot of threat assessments and we have a lot of orchestration around how we do those things. We're building right now a lot of automated systems and stuff like that, and I'm building a lot of agentic things internally for our own stuff. But yeah, definitely like the internal Atlassian system of work is pretty, like they do have a strong bias towards if the document, like HashiCorp was all about if it's not documented in a Git repo, then it doesn't exist. Atlassian is like if it's not on a Confluence page. So the source of truth is basically Jira tickets and Confluence pages. I do have some stuff that I worked on this where it can generate Atlassian document formatted outputs, so you can export it into like ADF, and then you can get different utilities to then use that to update Confluence pages. So your orchestration literally could be, you manage your threat model in your source code repository, the workflow then updates a Confluence page. But it's pretty hacky, like it's not at scale. Any other questions? Oh, yes, right up the back.
Is there a language server or plugins for that understand GraphCL? So, for example, if I want to open up this in the IDE, I get syntax highlighting.
Yeah, so I installed the Terraform one, and it kind of does some of the highlighting, but it doesn't, there's no LSP for the syntax of the specification. So you can make it look a little prettier, but it definitely won't go, hang on, you just typed, you know, in your data flow diagram, you've put a process, but you've typoed process. Like there's nothing like that. But that's a really good idea. Hope maybe that's not too difficult. If you are bored, please go to the GitHub site and feel free to have a look. And if you want to commit it yourself, that'd be magic. Awesome. Thank you all so much. I guess handing over to you folks.
More questions?